For question 8 we've got some coordinate geometry. It starts off by giving me 3 different points, so the first thing I've done is draw myself a little diagram. It doesn't have to be to scale, but it will give me a rough idea about what's going on. First part of the question, we're asked to show that AB is perpendicular to BC, which means we need to find some gradients. So we need to find the gradient of AB, and we need to find the gradient of BC. So our gradient formula is y2 minus y1 over x2 minus x1. And all we're going to do is we're going to do this for both AB and BC and see what we get. So for AB we're going to get, here's A, here's B. I'm going to use B as my y2, so I get 1 minus 3. And on the bottom, making sure the y's go on the top and the x's go on the bottom, we get 3 minus minus 1, which is minus 2 over 4, which is minus a half. So for B and C, we're going to use B and C. I'm going to use C to be my y2 and B to be my y1. So we get 5 minus 1. And then on the bottom we get 5 minus 3. On top we get 4, on the bottom we get 2, we get a gradient of 2. So we've found our 2 gradients, we've got one there and one there. All we need to do now is double check that these are actually perpendicular. The way of doing this is using the m times m perpendicular is minus 1. Product of their gradients must give you minus 1. So to check this, we do minus a half times 2 equals minus 1. This works, implies perpendicular. If, like me, you don't like writing the word perpendicular, they do accept this as the mathematical symbol for perpendicular. I'm actually now going to add the right angle to my diagram, because this is between AB and BC. You can see my diagram wasn't quite 100% accurate, but I nearly drew it as a right angle. It helps us see what we're doing. So on to part B, we're asked to find an equation for the straight line which passes through B and C. So if it passes through B and C, we know its gradient must be 2, because we found that out here. We found the gradient for B and C. We also know it passes through B and C. I'm going to use point B as my point, so this is 3, 1. And we're going to use the equation of a straight line formula, so this is y minus y1 equals m x minus x1. There are other versions of this formula. Some people have it as y minus y1 over x minus x1 equals m, which is that formula when we use for gradient. So some people write it that way, some people write it this way. Some people even use a y equals mx plus c and find c. This is the preferred method for EdXL. This is the one they use on the mark scheme and have done for many years. So we're going to use this one. So this is y minus 1 from here equals 2x minus 3. All we're going to do now is expand all of this. Implies y equals, we're going to get 2x here, we're going to get minus 6, add 1, this is minus 5. So there is our equation of a straight line. We do need to double check, going back to the question, that we're not specified to give it in a particular form, which we're not. It says an equation, so we can leave it just like that. For part C, we are asked to, we're given some more information. Straight line through A has equation this. The midpoint of AB is M. Determine an equation of a straight line which passes through M, so it passes through the midpoint of AB, and is parallel to the straight line through A and C. So we need to work out a couple of things here. We need a gradient and we need the point for M. So for C, M equals, we're going to use the coordinates A and B and the midpoint formula. So this is 3 plus minus 1 over 2, and the y coordinate we get 3 plus 1 over 2. This first one gives us 1, and this second one gives us 2. So that's our midpoint. We also need to have a look at our line formula. We actually know what the gradient is for this because it's perpendicular to AC, so parallel to AC. In fact, we don't have the gradient for AC. Let's use the line formula. So we know it's parallel to x minus 3y plus 10 equals 0. If we make this y equals mx plus c form, we can see the gradient. So we get 3y equals, I'm going to take this over to this side, x plus 10. Y equals 1/3 x plus 10 over 3. So m equals 1/3. What I've done here isn't great because I've used little m for both of them. Let's just make this a big capital M. And now it's easy to see the distinction between the two. All we need to do now is use our line equation formula. So y minus y1, which in this case is a 2, equals m 1/3 x minus x1 is 1. So we get y equals 1/3 x minus 1/3 plus 2. Minus 1/3 plus 2 implies y equals 1/3 x minus 1/3 plus 2 gives us 5/3. I'm just going to add this to my diagram. So this is the midpoint here between A and B, and it's parallel to this. So for part D, we're told a straight line which passes through M is parallel to the straight line AC, so this is the line we've just found, meets BC at point P. Meets BC, B to C, here's point P. State the coordinates of P. So this is something we should be able to do without extensive working out. Some of you are already looking at this and going simultaneous equations. We've got this equation of this line here, and we can find the equation of this line here, but for 2 marks, for a state question, it should be easier than that. If these lines are parallel, and this is the midpoint here, then this must be the midpoint here. So P, it's either the intersection, or it's just the midpoint of BC. You wouldn't lose marks in the exam if you worked out the simultaneous equations and got all the way to the end, but you're going to be using up valuable time. So this is just the midpoint of BC, so this is 3 plus 5 over 2, and the second part is 1 plus 5 over 2. So the midpoint here, P equals, this is 8 over 2, which is 4, and this is 6, which gives us 3. And that's the end. We don't need to do the simultaneous equations because in this case it's turned out that this is also the midpoint, but we could, if you're stuck and you don't spot that as a solution, you can do the simultaneous equations and you should arrive at the same point.